computer also. Um, okay. So a similar expression was derived for the magnetic field also, and we had for magnetic field of this form. So these were our equations which we need to solve if I want to get an expression for electric field or magnetic field. I said that for any particle or for any plane wave which is traveling in the positive x direction, if you have a plane wave in positive x direction, and you might have seen this expression that you write it on this form. You can write it sine, you can write it cosine, you can write it exponential also. Or cosine also, any of them, that is your choice here. This represents, if here you have k represents your wave vector, x represents the direction of propagation of waves. If you are claiming that your wave is propagating in x direction, then you are writing kx. If you would have been saying that, okay, your wave is traveling in the z direction, then you had to write here kz minus omega t. We are sticking to the one dimensional case here. अगर आपका 3D में होता तो आपके पास kx plus ky plus kz आपको तीनों अकाउंट में लेने पड़ते. But now for simplicity, let's say that we are just talking about one direction कि आपका जो wave है वो positive x direction में move कर रहा है. Positive के बजाय अगर negative x direction होती तो minus omega t की बजाय आपका plus omega t हो जाता. That would have been the difference. And then I said that you need to find out the relationship in this expression between these terms. And I claimed that this expression would be equal to v square, where I'm saying that your v square is equal to omega over k. I hope you might have already done this derivation using any of these expressions, sine, cosine, or exponential, anything of your choice. And I'm claiming that you will get this expression. If you still haven't done that, please go back and do it again. Now, this was for your plane wave, which was traveling in one day, right? And we said that if I get a relationship between second order differentiation with respect to x and second order differentiation with respect to time, we'll have this relationship here. Now, I would like you to compare this equation or the magnetic field equation with equation number 3 here. Del square is nothing but your differentiation in 3D. This is what we called del square from the previous class. Right? So, as I said before, we are taking this plane wave in one direction only. अगर आप इसको 3D में लेते तो आपके पास में यहाँ पे curly square, and then I shouldn't have taken it y because x, y, z आपके 3 coordinate होते. Let's say ये f होता तो आपके पास curly square f by curly x square plus curly square f by curly y square plus curly square f by curly z square होता अगर ये 3D में होता, right? So now if you compare equation 1 and 2 with equation 3, equation 1 says that, let me just do the electric field. It is similar for the magnetic field. So we can just do one of them and the other one you can simply write similarly. The same will be the case for the second one also. So here then I can say that if I want to draw it, if I want to write this equation 1 in the same form exactly as is equation 3, then I can say that 1 upon mu naught epsilon naught del square E is equal to curly square E over curly T square. I have just taken this term on the left hand side. As I said before, del square is basically your 3-dimensional derivative, which is equivalent to here curly square y by curly x square is basically equivalent to this term, right? Y is basically your E now here. If you compare these two equations, by comparing these two equations, then I can claim that for electric field, if I have a v square term here, then for electric field, your v square is equal to 1 upon mu naught epsilon naught. क्योंकि आप कह रहे हो अगर आपकी प्लेन वेव एक पॉजिटिव एक्स डायरेक्शन में ट्रेवल करती है और अगर उसका सॉल्यूशन इस फॉर्म में है तो ये दोनों टर्म इस वे में रिलेटेड होंगे v स्क्वायर. I have exactly similar expression for electric field and magnetic field in 3D. Then from equivalence between these two equations, अगर यहाँ पे आपका v square आ रहा है तो ये वाली टर्म भी आपकी v square होनी चाहिए. If your v square is equal to 1 upon mu naught epsilon naught, that basically would mean that your v is equal to 1 upon square root of mu naught epsilon naught. अब अगर आप इसमें if you plug in the value of permeability and permittivity of free space, what you get is something which is 2.98 or 99, I think 2.99 into 10 raised to power 8 meter per second. You can do that yourself, plug in the value of mu naught and epsilon naught and see if you get the V to be equal to 3 into 10 raised to power 8 meter per second. And hence, you can now say that your electric field is moving with velocity which is equal to the speed of light. Equation 1 and equation 2, they are exactly similar to each other. If your E is moving with velocity being equal to speed of light, that would mean that your magnetic field is also moving with the same speed. Hence, if your electric field and magnetic field are moving with the speed of light, and your electromagnetic waves is nothing but oscillating electric field and magnetic field, hence you can prove that your electromagnetic waves, they travel with the speed of light. This is the proof, mathematical proof that your electromagnetic waves, they are going to travel with the speed of light. We have proved that your electric field will travel with the speed of light, your magnetic field will travel with the speed of light, and if your electromagnetic waves are made up of oscillating electric field and magnetic field, then your electromagnetic waves also had to travel with the speed of light. So this is the proof for the your velocity being equal to c for electromagnetic waves. Now, the second part, we are going to prove that these electromagnetic waves are also transverse in nature. For doing that, let's compare again this equation 1, equation 2 and equation 3. अगर ये equation 3 जो है, equation 1 और equation 2 के equivalent है, तो अगर equation 3 का solution was given by this form, and here for our own convenience, we will take the solution of the exponential form. The reason being that because we have to take time and again second order derivative with respect to space, second order derivative with respect to time in the next coming lectures. And if you want to take the derivative with respect to time and space, then dealing with exponential will be much easier as compared to dealing with sine or cosine. क्योंकि sine को आप cosine में करोगे, फिर sine में करोगे, and so on. Hence, what we are going to do is that now we are going to stick with the exponential solution here. So if equation 1, equation 2 and equation 3, they are similar to each other, and for equation 3, if you have solution of this form, then equation 1 and equation 2 also has to have a similar kind of solution. That means your electric field and magnetic field equation, which are equation 1 and 2, they will have this kind of solution here. And now I'm going to write the solution here. And I'll tell you why I'm going to write it in a slightly, probably complicated way for you. Previous slide mein, we did take it a simple solution. We said a e raised to power iota kx minus omega t. Simple, this solution was there. Now I have made it complicated. The reason being that your electric field is a vector quantity. So it needs to have magnitude as well as direction, both of them. So this term here basically represents your magnitude as well as direction. I'm going to decompose it into 3 components because now I am saying that we do not know electromagnetic waves are transverse in nature. So I am going to say that your electric field is in all the possible directions. It is going to be there in x direction, it is going to be there in y direction as well, and it is going to be in z direction also. because so far we do not know if your electromagnetic waves are transverse in nature. Hence, I have to take electric field in all the possible directions. Once we prove them in transverse, then we can stick to one direction, that your electric field, if it is in the x direction, your magnetic field will be in the y direction, and your direction of propagation would be in the z direction. Because then we are going to prove that your wave vector, which basically tells you direction of propagation, is perpendicular to your electric field, and that is perpendicular to your magnetic field. We are going to prove that. But as of now, because we do not know that they are perpendicular to each other, so we are going to assume every possible direction. So I'm saying that your electric field is there in all the three directions. And here I have written k dot r rather than kx, because in the kx you are saying that your wave was propagating in the x direction. Now I am taking the general solution and I am saying that your electromagnetic wave can travel in x direction, it can travel in the y direction, and it can travel in the z direction also. There is nothing which is stopping it from traveling in all the possible directions. On the top of that, I am also going to say that if this is your origin, and let's say on this side there is one axis, and this side you have second axis, and third axis is in this direction. I'm going to say that your wavelength of this electromagnetic wave is going to be different in this direction, it is going to be different in this direction, and it is going to be different in this direction, just to get us the maximum freedom with the variables here. If your wavelength is different in different directions, that means your wave vector, which is basically 2 pi by lambda, right? Your wave vector is going to be different in different directions. Your wave vector, let's say along the x-axis, if I want to write k dot r, let's say that that is basically being equal to, I have k vector in the x direction, I have the k vector in y direction. Subscript here denotes that I'm talking about your k vector, your wavelength in the x direction. And then I have a different wavelength and hence a different wave vector in the y direction. And we have a different wavelength and different wave vector in z direction also. R is nothing but simply x dot x unit vector plus y unit vector plus z unit. अगर आप इन तीनों का डॉट प्रोडक्ट लोगे, you will get simply this. Kx is single quantity here. Ky is single quantity. The subscript here denotes that I'm talking about the wave vector in the y direction. And this then is further multiplied by x here. So I'm saying that you have a wave which is moving in all the possible three directions, but on the top of that, this wave has different wavelength in all the possible directions. And then I'll have minus omega t. I can write this in this form also. Let me repeat that. Right now, we are assuming that your electric field is in all the three directions, in the x direction, y direction, z direction. Your wave is propagating in all the three directions. And similarly, your magnetic field is also in all the possible three directions. I'm going to write exactly same expression for the magnetic field also. So you have everything in all the three directions. But if your electromagnetic waves are transverse in nature, then they cannot be in all the possible three directions. If you fix the direction of electric field and let's say magnetic field, then the direction of propagation is automatically fixed. If you say that, अगर आप कह रहे हो कि मेरा इलेक्ट्रिक फील्ड सिर्फ एक्स एक्सिस में हो सकता है, एंड दैट मीन्स आपका मैग्नेटिक फील्ड और आपकी डायरेक्शन ऑफ प्रोपेगेशन वो एक्स एक्सिस में नहीं हो सकती है if they are transverse in nature. That would mean that your magnetic field can be either in y direction or in z direction. And let's say that if I claim that my magnetic field is in y direction, then your direction of propagation can only be in the z direction. That is meant by being transverse in nature. So right now we are assuming that it is not transverse in nature. We do not know that if it is transverse in nature. So let's have our electric field and magnetic field in every possible direction, and let's have the direction of propagation also in every possible direction. Now for simplicity, many times what is done is that this is further written as EXX unit vector plus EYY unit vector plus EZZ unit vector, where I'm saying that we get rid of these terms here. Where I'm now claiming that my EX is nothing but E0X multiplied by this exponential term. Similarly, EY is a product of E0Y. अगर आप इसका y यूनिट वेक्टर के अलावा जो भी कुछ टर्म बचती हैं वो सारी की सारी you put them together. And then you have EZ. Similarly, you can do for the magnetic field also. यहाँ पे E0X is telling electric field का along the x-axis इतना magnitude है. Electric field का along the y-axis this much is the magnitude. Electric field का along the z-axis this is the amplitude. And then this basically adds the traveling component in your wave or in your electric field here. So I can write electric field here then in this form, and I can write magnetic field in this form also. Now I'm going to use this expression back in the Maxwell's equation and prove that your electromagnetic waves are transverse in nature. Let's do that. Your Maxwell's first equation says that del dot E is equal to 0, which basically means that you have del operator
Excuse me, ma'am.
Hanji.
Can you please go back to the previous slide?
Hanji bache.
Thank you, ma'am.
You done?
Yes, ma'am, done. Thank you.
Okay. And then I'll have the अगर आप इसका डॉट प्रोडक्ट लोगे, this is equal to 0. If you take the dot product of this, what you will get is this number here. Simply by the dot product rule here. From the previous slide, Ex is equal to E0x e raised to power iota kxx plus kyy plus kzz minus omega t. This was how we approximated Ex. If you take its derivative, this would imply if I take its derivative with respect to x, E0x is basically your amplitude along the x-axis, which is constant. So this is as it is. Exponential term, if you look at the exponential term, take the derivative with respect to x, what you will get is iota times kx, right? kx के साथ में x है, x का with respect to x डेरिवेटिव लोगे 1 आ जाएगा. उसके अलावा बाकी ये जो तीन टर्म बची हैं, करली y करली x 0 होगा, करली z करली x 0 होगा, ओमेगा t का भी आप with respect to x डिफरेंशिएशन करोगे वो 0 होगा. एंड एक्सपोनेंशियल टर्म आपकी फिर as it is वापस आ जानी चाहिए. Simple from the derivation rule. You will have everything as it is. Remaining terms also here. Iota kx, this is nothing. If you put these terms together, these are nothing but your Ex back. So this is your curly X by curly X. अगर आप Ex जो X डायरेक्शन के along कंपोनेंट है, अगर आप उसका with respect to X डेरिवेटिव लोगे तो आपको ये एक्सप्रेशन मिलेगा. Based on the similar logic, अगर आप with respect to Y करोगे, जो आपकी सेकेंड टर्म है कि जो y कंपोनेंट है इलेक्ट्रिक फील्ड का उसका विद रिस्पेक्ट टू y डेरिवेटिव करोगे, आई एम क्लेमिंग दैट यू विल गेट दिस एक्सप्रेशन। एंड क्योंकि जब आपने विद रिस्पेक्ट टू x किया तो आपको आयोटा kx मिला, ex जो है वो एज इट इज मिल गया। विद रिस्पेक्ट टू y करोगे, आई एम सेइंग दैट आयोटा ky मिलेगा और ey आपको एज इट इज मिल जाएगा। एंड अगर आप z कंपोनेंट का विद रिस्पेक्ट टू z डेरिवेटिव करोगे तो आपको मिलेगा this back as it is. You can do the mathematics. आपको EY पता है, आपको EZ पता है। विद रिस्पेक्ट टू Y अगर आप डेरिवेटिव करोगे ये आपका एज इट इज आ जाएगा, इसका डिफरेंशिएशन 0 हो जाएगा, आयोटा KY मिल जाएगा, करली Y बाई करली Y 1 हो जाएगा, बाकी टर्म्स का भी 0 होगा एंड यू विल गेट द सिमिलर एक्सप्रेशन हियर। नाउ दिस इक्वेशन देन, इसमें अगर आप ये सब वैल्यू प्लग इन करते हैं देन यू आर सेइंग आयोटा kx ex plus iota ky ey plus iota kz ez is equal to 0. I can say that iota तीनों में कॉमन है, take it out and then this is nothing but saying that this is equal to 0. Because you will have kx ex plus ky ey plus kz ez, which is nothing but the dot product of k vector with e vector. Now, if the dot product of any two vectors is 0, that means those two vectors are perpendicular to each other, right? This would imply that k is perpendicular to e. Your direction of propagation is perpendicular to the electric vector. I should draw arrows here because their dot product is equal to 0. Now, I'm not going to do it for the magnetic field. Del dot B is 0 as per Maxwell's second equation. If del dot B is equal to 0, exactly follow the same step, follow exactly the same steps, and then you can prove that K is perpendicular to B also. Because magnetic field shows exactly the same behavior as is shown by the electric field. आपकी सारी की सारी terms are exactly similar to each other. Hence, if your del dot B is equal to 0, then you can prove that K is perpendicular to B also. Now, if I'm saying that del dot B is also 0, and since electric field and magnetic field are showing exactly similar behavior, this would imply that your K is perpendicular to B. But what we have done is that we have proved that K is perpendicular to E, and we are proving that K is perpendicular to B. But we haven't said anything about E and B. E और B एक दूसरे के perpendicular हैं या नहीं हैं, we haven't said that. हम simply बस ये कह रहे हैं कि आपकी direction of propagation है वो electric field और magnetic field के perpendicular है. This means that you are saying that your electric field can be still in the same direction. आपका इलेक्ट्रिक फील्ड मैग्नेटिक फील्ड दोनों एक्स एक्सिस में हो सकते हैं, और अगर आपकी डायरेक्शन ऑफ प्रोपगेशन इज जेड एक्सिस, still you are satisfying these conditions that your K is perpendicular to E and B. But then we need to prove that your E is also perpendicular to B. Right? अगर आप अब ये भी प्रूव कर देते हो कि आपका E और B they are perpendicular to each other, then you can conclude that all the three vectors are mutually perpendicular to each other. How we can do that? Go to Maxwell's third equation. Maxwell's third equation says that del cross E is equal to minus curly B by curly T. This is your Maxwell's third equation. In free space. It is same in medium also, but since we are talking about the free space, so let's talk about just in the free space. Del cross E. Now let's first deal with left hand side and then we'll deal with right hand side. Your left hand side is del cross E. Vector, you know how to do the vector product. You will have this del curly by curly x, curly by curly y, curly by curly z. E के आपके तीन कंपोनेंट होंगे, ex, ey, ez. यहाँ से then I can say that this would be equal to curly ey, curly sorry, curly Ez by curly y minus, and then this would come with this curly Ey by curly z minus y unit vector, you will have curly Ez by curly x, and then curly Ex over curly z, plus z unit vector, and then you will have curly Ey by curly x minus curly Ex over curly y. This is your from the simple vector product here. Now again, I'll just do it for these two terms, and then I'll conclude that similarly for the rest of the terms, you'll get the similar derivation. सिर्फ दो terms का मैं derivation करूंगी, and then we'll say for the rest of the terms, similarly you can derive the expression. So let's talk about first Ez. Ez was nothing but E0z e raised to power iota kxx plus kyy plus kzz minus omega t. Now अगर आप इसका with respect to y differentiation करते हो, which is the first term here, what you will get is that E0z as it is आ जाएगा क्योंकि it's simply amplitude. उसके बाद में exponential term जो है वो आपकी as it is आएगी iota kxx plus kyy plus kzz minus omega t. उसके बाद में एक्सपोनेंशियल टर्म का अगर आप डेरिवेटिव करना स्टार्ट करोगे, आयोटा आपका बाहर आ गया. ब्रैकेट वाली टर्म का विद रिस्पेक्ट टू y डिफरेंशिएशन करोगे, kx x का विद रिस्पेक्ट टू y डिफरेंशिएशन करोगे 0 आ जाएगा. ky y का विद रिस्पेक्ट टू y डिफरेंशिएशन करोगे आपको ky मिल जाएगा. kz z का विद रिस्पेक्ट टू y डिफरेंशिएशन करोगे 0 आएगा. ओमेगा t का भी विद रिस्पेक्ट टू y डिफरेंशिएशन 0 आएगा. सो आपको ये वाली टर्म मिलेगी. And this is nothing but iota ky, और ये वाली जो term है, this is same as was the this term. This is nothing but Ez. अब अगर आप Ey की बात करते हैं, your Ey was nothing but E0y e raised to power iota kxx plus kyy plus kzz minus omega t. अब अगर मैं इसका विद रिस्पेक्ट टू z डिफरेंशिएशन करती हूं तो ये वाली टर्म आपकी एज इट इज आएगी, ये पूरा एक्सपोनेंशियल एज इट इज आ जाएगा, विच इज नथिंग बट Ey. फिर एक्सपोनेंशियल वाली जो टर्म है उसका अगर आप विद रिस्पेक्ट टू z डिफरेंशिएशन करोगे, आयोटा आपका बाहर आ जाएगा. kxx का विद रिस्पेक्ट टू z डिफरेंशिएशन करोगे 0 आएगा. ky y का विद रिस्पेक्ट टू z डिफरेंशिएशन करोगे आप यू विल गेट 0. kz z का अगर विद रिस्पेक्ट टू z डिफरेंशिएशन करोगे यू विल गेट kz. ओमेगा t का विद रिस्पेक्ट टू z डिफरेंशिएशन वुड बी 0. सो डू यू सी अ पैटर्न हियर? विद रिस्पेक्ट टू y अगर आपने डिफरेंशिएशन किया तो आपका आया आयोटा ky. Ez का डिफरेंशिएशन किया, Ez came as it is. Similarly, when you differentiated Ey with respect to z, you get iota kz and then Ey as it is. So there is a very clear pattern here, and based on that pattern, I can write rest of the terms here. With respect to x अगर आप डिफरेंशिएशन करोगे आपको मिलेगा iota kx. Ez का कर रहे हो, you will get Ez as it is, and similarly here you will get iota kz and then Ex would come as it is, plus z unit vector, and then here with respect to x you are differentiating, so you will get iota kx and then you will have Ey as it is minus iota ky and then you will have Ex as it is. Iota is common everywhere. You can take iota out from every single term here. You have ky Ez minus kz Ey, kx Ez minus kz Ex, kx Ey minus ky Ex. I am claiming this is nothing but k cross E. You can verify that by yourself. Just take the vector product of k with E and see if you get this term here. If you do not get this term, we can do the derivation in next class. But it's very simple vector product. K का आप with respect to E, आप vector product लीजिए, you should get this term back here. So I'm saying that your del cross E is basically equal to this term here. Now let's talk about the right hand side here. The right hand side is minus curly B by curly T. B is nothing but simply your B0 e raised to power iota kxx plus kyy plus kzz minus omega t. I haven't written it in three components, B0xx plus B0yy plus B0zz. The reason being that those are simply space coordinates. And now we are interested in taking its derivative with respect to time. Hence, I do not need to decompose it into further components here. So if I take the derivative with respect to time of this term here, what I'll get is minus as from here. Your B naught will come as it is. You will have this exponential term also as it is. And then if you take the derivative of this term with respect to time, you will get minus iota omega. Iota minus omega from here. In तीनों term का with respect to time derivative would be 0 because your time and space coordinates are independent of each other. So you have minus minus would become plus here. You will have iota omega, and this term is nothing but your magnetic field back here. So this will be your right hand side of Maxwell's third equation. Left hand side was equal to this term, right hand side was equal to this term. So now if we put both of these terms equal to each other, that means then we are saying that iota k cross E is basically equal to iota omega B. Iota से आपका iota cancel हो गया. So from here you are saying that k cross E is equal to omega B. If you have any two vector and take the cross product of those two vectors, the outcome will be perpendicular to both of the vectors, right? I'm repeating that if you have any two vectors and if you take the cross product of these two vectors, then the outcome is perpendicular to both of the vectors, right? आपका cross product का जो outcome आता है वो दोनों vectors के perpendicular होता है. So from this equation then you can say that your k is going to be perpendicular to B and your E is going to be also perpendicular to B. So even without proving that del dot B is equal to 0, इसमें prove किए बिना भी simply by using first equation and third equation, you can prove that electromagnetic waves are transverse in nature. Because from the first equation, if you go back to the equation number 1, you did prove that K is perpendicular to E, and from this equation here, we can claim that your B is perpendicular to K and B is perpendicular to E also. But we already proved that K is perpendicular to E. So from these three equations, then you can claim that all the three of them are mutually perpendicular to each other. अगर आपका इलेक्ट्रिक फील्ड एक्स एक्सिस में है तो आपका मैग्नेटिक फील्ड एक्स एक्सिस में नहीं हो सकता, आपकी डायरेक्शन ऑफ प्रोपेगेशन भी एक्स एक्सिस में नहीं हो सकती है. आपका अगर आपने लेट्स से इलेक्ट्रिक फील्ड की जो डायरेक्शन है वो अगर आपने एक्स एक्सिस फिक्स कर दी है तो योर मैग्नेटिक फील्ड कैन बी इन वाई और जेड एक्सिस, किसी में भी हो सकता है. बट लेट्स से दैट यू हैव फिक्स्ड द डायरेक्शन ऑफ मैग्नेटिक फील्ड आल्सो along the z axis. In that case, your K can only and only be in the y axis. That is the only choice it has. Unpolarized light, the light that we get from the bulbs in our houses, what happens in those lights? The direction of electric fields keep on changing continuously. एक बार वो x एक्सिस पे होगा, वो एक बार फिर x एक्सिस और y एक्सिस पे सब in between होगा, then it would be on the y axis, then it would be in between y and z axis, and then it will be along the z axis. और जैसे जैसे इलेक्ट्रिक फील्ड की डायरेक्शन चेंज होती जाएगी, ऑटोमेटिकली आपके मैग्नेटिक फील्ड और डायरेक्शन ऑफ प्रोपगेशन भी ऑटोमेटिकली चेंज होते चले जाएंगे. So in unpolarized light, what happens is that your direction of electric field, your direction of magnetic field, as well as direction of propagation of wave keeps on changing very continuously and very rapidly also. But if you have a polarized light, in the polarized light, your direction of electric field, if we are talking about a plain polarized light, then your direction of electric field is going to be fixed in one direction. आपका electric field सिर्फ एक direction के along ही oscillate करेगा. It cannot keep on oscillating in any random direction. You have to fix the direction of oscillation of electric field. So now we have proved that your electromagnetic waves are transverse in nature. I'll just take a couple of minutes, a quick derivation from similarly from this place also. We said that K cross E is equal to omega times B. This is what we proved just now. K cross E is equal to omega times B. If you solve this, then you will say that K E sine, we know that K is perpendicular to E. So the angle has to be 90 degree is equal to omega times B here. For electric field, if your electric field is E0, e raised to power iota K dot R minus omega t. I'm now again writing it in a slightly better form because I don't want to differentiate or anything here as of now. If I want to take the modulus of this vector here, this would be given by dot product of this vector with the complex conjugate of this vector itself. This is how you calculate the modulus of vectors. You might already know this form. So this would mean that if this is your E, then your E star, let me write that here itself, would be equal to E0 star, e raised to power iota would become minus K dot R minus omega t. That would mean that this would come out to be E0 with E0 complex conjugate. E0 being a scalar quantity, this would be simply your E0 vector magnitude, right? Because rest of the term e raised to power plus iota tha or e raised to power minus iota tha, they will cancel each other out. And आपके पास में सिर्फ E0, E0 star बचेगा. Similarly, you can prove for the magnetic field also that this would be equal to your B here. You can prove that because we said that your magnetic field is also of the exactly same form. This was the expression for a magnetic field. Exactly on the similar step, then you can claim that your magnitude of the magnetic field would be given by the dot product of this vector with the complex conjugate of the vector itself. So from here, then I can say that modulus of K is K, modulus of E is going to be E naught, sine 90 is 1 is equal to omega times B naught. So from here, and I'm going to conclude something interesting here, E naught upon B naught is equal to omega over K. Omega is 2 pi by T, K is 2 pi by lambda. 2 pi से 2 pi cancel हो गया. 1 upon T is frequency. This is equal to, this is multiplied by lambda, which is nothing but equal to C, right? C is equal to nu times lambda. So from here, then you are saying that E naught is equal to C times B naught. It has very interesting meaning. This means that when electromagnetic waves are moving, the magnitude of electric field is 3 into 10 raised to power 8 times magnitude of magnetic field. आपका मैग्नीट्यूड अगर आप बात करें मैग्नेटिक फील्ड का वो बहुत 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 स्मॉल होता है एज कंपेयर टू द मैग्नीट्यूड ऑफ इलेक्ट्रिक फील्ड. आपका इलेक्ट्रिक फील्ड का जो मैग्नीट्यूड है वो C टाइम्स and C is 3 into 10 raised to power 8 times magnitude of magnetic field होता है, and 10 raised to power 8 is a very huge factor. तो आपकी इलेक्ट्रोमैग्नेटिक वेव्स हैं, दे आर मोस्टली मेड अप ऑफ बेसिकली इलेक्ट्रिक फील्ड. मैग्नेटिक फील्ड का जो कंपोनेंट होता है, that is a very necessary component. When I'm saying that your electromagnetic waves are mainly made of electric field, that does not mean कि आप simply electric field से electromagnetic wave produce करा सकते हैं. No, this means that electric field magnitude is so large as compared to the magnitude of magnetic field. कि आपका magnitude जो magnetic field का है, that is extremely small. And this is the reason conventionally जब आप polarized light की बात करते हो, and if someone says that the direction of polarization of light is along x-axis, that means your electric field is oscillating along the x-axis. क्योंकि conventionally electric field is used for denoting the direction of polarization of electromagnetic waves. The reason being that magnitude of electric field is so large as compared to the magnitude of magnetic field. And I'll stop here. Anyone has any doubt in today's class? No. Okay, I'll pick from here. I'll use the expressions from today's class, and the next two classes are going to be a bit more mathematical as compared to these classes also. So do stick with me. If you have any doubts, ask me. And for electromagnetic waves, please do not follow N.K. Verma. There are a lot of typographical error in that book. So for electromagnetic waves, please do not follow that book. You can either simply stick to the lectures, or there is a book by Introduction to Electrodynamics by David J. Griffiths. LMS पे इसके पेजेस के स्पेसिफिक डिटेल्स दिए गए हैं कि आप कौन कौन सी पेजेस में से कर सकते हैं. आपके जो लेक्चर्स हैं वो गूगल ड्राइव पे मैंने अपलोड कर दिए हैं. आपके सीआर को लिंक भेज दिया है लेक्चर, बट आप तभी एक्सेस कर पाओगे जब आप थापर का ईमेल एड्रेस यूज करके एक्सेस करना चाहोगे. अपने पर्सनल जीमेल से आप लेक्चर एक्सेस नहीं कर पाओगे. सो देयर आर अ लॉट ऑफ स्टूडेंट्स जो अपने पर्सनल जीमेल अकाउंट से लॉगिन या एक्सेस करने का ट्राई कर रहे हैं वो लेक्चर्स. यू वोंट बी एबल टू डू दैट.
मैम,
हाँ जी.
Ma'am, in the case of a parallel plate capacitor, ma'am, like the conduction current magnitude is not equal to the means it may or may not be equal to the displacement current. So, ma'am, does it not violate the principle of charge conservation?
No, it doesn't. क्योंकि आपको हमने प्रूव किया था ना लास्ट वाली क्लास में that your JC becomes equal. You can prove that कि आपका line integral of B dot DL is equal to mu naught I even in between the plates. जो additional term आई थी mu naught epsilon naught curly by curly T, वहां से वो हम लोगों ने प्रूव किया था.
Okay, ma'am.
आप एक बार प्रीवियस लेक्चर दोबारा देखिए जहाँ पे पैरेलल प्लेट कैपेसिटर को दोबारा डिस्कस किया गया था after addition of displacement current, and if you still don't follow that, then let me know.
Okay, ma'am.
हाँ जी.